Recording in progress.
This is a fourth edition. Hello?
Yes.
Fourth edition.
Okay. There will be slight changes in.
By 100
Recording
degrees.
in progress.
Yes. Melting is basically like if someone asks you how ice melts. So what your answer would be? You will say the ice will absorb some of the energy from the environment. You know, when you place ice outside the refrigerator, what happens? After some time, it melts. Why it melts?
Yeah.
Because that ice absorbed heat energy from the environment. Okay, it absorbed that heat energy, and heat energy. What is the function of that heat energy? That will break the intermolecular forces present in the ice. Okay. And when the intermolecular forces will break, what will form? The liquid will form. Because we
Yeah.
have discussed in the first class that the solids have strong intermolecular forces, right? So ice,
Yeah.
initially the ice was having strong forces. When it absorbs energy, what will happen? That energy will break those forces, okay? And then that ice will convert into liquid. Are you getting my point, what I'm saying? Like this was initially, this was the ice. This is like, and there are strong forces in. So when you place this ice cube in the room, uh, not in the refrigerator, but you have taken it from the refrigerator and you have placed it in the room in a glass. Okay, so what will happen? It will absorb the heat energy from the room. Okay, and that heat energy will what this heat energy will do? It will break these intermolecular interactions. Okay, it will break the intermolecular forces. Okay, and when the intermolecular forces will break, what will happen? It will convert into liquid. Yes, and you know, in liquid there are less intermolecular interactions as compared to the solid. That is why we say
Yeah.
that the solid, when you are converting a solid into liquid, it needs energy. Okay, it needs energy. It will absorb heat energy. And similarly, you have a liquid. So this liquid, if you are heating it, how it will convert into gas? That heat energy is used to break what? The intermolecular interactions present in it. Okay, present in the liquid. So what is the purpose of heat energy? To break the forces. Okay, to break those
Yeah.
bonded forces by which the liquid was bonded. So once those forces are break, what will happen? It will, the gas molecule
Liquid.
will, yeah, the liquid will convert into gas. Okay.
Yeah.
The particles, when the intermolecular forces will break, what will happen? The vibrations will increase. Actually, in liquid, you know, in liquid there are vibrations. There are more
Yeah.
vibrations as compared to solid. So when you are heating it, the vibrations will increase more. Okay, there will be
Yeah.
increased number of vibrations, and when the vibrations will increase, what will happen? The gas will form. After some time,
Yeah.
the at boiling point, the gas will form. Okay, are you clear with this difference?
Yeah.
The melting and boiling point. So how this happens?
Yeah.
You will say by the use of heat energy. The heat energy will be used, and what is the function of that heat energy? That heat energy is used to break those intermolecular
Forces.
forces. Yes. Okay. Clear?
Yes.
Okay. Afterwards, we started with the evaporation. What is evaporation? Like when we discussed that from the liquid, the boiling is what? The conversion of liquid into gas, right?
Yes.
The liquid into the gas. Are you following the book for chemistry as well? Hmm? Did you study from the
Yes.
book? Okay, study from the book. And you, if you have a book right now, you can write things of, like with a pencil, not with a pen, because you can erase if
Yeah.
there's something wrong. Okay, or you can add sticky note on the book. It will help you.
Yeah.
Okay. Then in evaporation, what happens? Evaporation and boiling are two different things. In evaporation, sometimes some of the molecules present on the surface of the liquid, they escape. Okay,
Mhm.
they escape this liquid. They leave this liquid. Okay, so this is known as evaporation. That some of the gas molecules will leave the surface. This is known as evaporation, and it will happen uh, when these molecules will gain enough energy to escape. Okay, when they will
Mhm.
have enough energy to escape and form a gas.
Mhm.
Remember, this line is very important. Okay,
Yeah.
so this is evaporation. And what is the basic difference between evaporation and boiling? This I gave you. I think I gave you the task, right? For the difference between evaporation and boiling.
Yeah.
What is the difference?
What's it called? Like evaporation is,
Hmm.
like, and
This is what is this? It is a
when
surface
when
phenomenon.
yeah, like the vapor when the liquid turns into gases, the surface,
Hmm.
at the surface, the vapor
Yeah, evaporation is a surface phenomena, while boiling happens throughout the liquid. You see, the boiling happens
inside.
throughout. Yes,
Yeah.
throughout inside the liquid. It is not on the surface, it is throughout in it. And okay, one more difference I told you was that boiling happen at specific temperature. Okay, it needs a specific temperature. Boiling happens at specific temperature. But for evaporation, you don't need any specific temperature. Just like I gave you the example of water. You know the boiling point of water is
100
100.
degrees.
Okay, it cannot boil at 98 or 99. It
Mm-hmm.
can evaporate at 98 or 99, but it cannot boil. It will boil only at 100 degrees Celsius. Clear?
Yeah.
What I am saying is that
Yes.
at 98, 97, or maybe at 67, it will evaporate. Okay? Water can evaporate at these temperatures because for evaporation, you don't need a specific temperature. But for boiling, you need a specific temperature. Clear? So these are the two differences. First difference is that evaporation is a surface phenomena, while boiling happens throughout the liquid. Okay, boiling occurs throughout the liquid.
Mhm.
While the second difference in the boiling and evaporation is what? That the evaporation can happen at any temperature, while boiling happens at a specific temperature. This is
Mhm.
important. It is asked in the P2 for the 2 marks. Okay. You can
Okay.
mark over here. You can place a star over here. And what you can do, you can write the question with a pencil. The difference between evaporation and boiling. So this is how you can, because it is difficult to make notes. Obviously, you are going school and you are taking other classes as well. So with class, you can write on the book. Difference between
Mhm.
within the class, you can do this. Evaporation and boiling. Okay.
Mhm.
Can you recall the difference? Firstly, you can write and then tell me.
Okay, so
Hmm.
just give me 1 minute.
Or you can take the screenshot after the class. You can write. It's up to you.
Okay, I'll just do it. Yeah, I'll just do this.
Okay.
Okay. Okay.
Yeah, I am asking you now. Can you tell me what are two basic differences between evaporation and boiling? Even though they look similar, right?
Evap Yeah, evaporation happens at the surface, and when melting happens inside the liquid
Hmm.
at a specific boiling temperature, and evaporation doesn't have a specific temperature.
Hmm. Okay. Boiling. You can say evaporation can happen at any temperature. Okay,
Yeah.
but boiling will occur only at specific temperature. Okay, your concept is right, but sometimes now your time is to know how to write answers. Most of the time, the
Mm.
students they lack at this stage in writing. They know the concept, but they don't know how to put that information exactly according to the
Mhm.
exam point of view. So this is how you will write. Okay. And yes, one more thing we discussed was the kinetic particular theory. You remember that?
Uh, no.
Okay, let me explain it again. In the kinetic particle theory, we discussed that what is meant by kinetic. Kinetic means movement. Okay,
Movement.
yeah, movement. Particle means the particles theory. So it
Yeah.
this theory tells you the movement of the particles, how the particles move. Okay, how the particles in the gas, liquid, or solid they move. Firstly, a substance can be solid, a liquid, or a gas, and change from one state to another. This we have
Mhm.
already discussed that how the state changes, how a solid can change into liquid, or how a liquid can change into gas. Clear?
Yeah. Mhm.
If I ask you liquid to gas, what is this? Is this melting, boiling, freezing? What is this?
This is melting.
This is melting. This is
Boiling,
not.
boiling,
Yeah,
boiling,
this
boiling.
is boiling. Okay. Yeah.
Yeah.
So you must know. They can ask you like this. Okay. Then the second thing is the kinetic particle theory. What it tells you? Firstly, it tells you that a substance can be a solid, a liquid, or a gas, and it can change its state. Okay. Second is it has different characteristic in each state. You know this, right? Like if you have
Yeah.
water, the in the liquid form it have different characteristics, and in the gaseous form it will have different characteristics. Clear?
Mm.
Are you clear with the difference?
Yeah.
Like in the liquid, you will say in the liquid, the water molecules, the particles will be close to each other, while in the gases, there will be no intermolecular interactions when the water is in the form of
Mhm.
gas. And similarly, for example, solid do not flow. Like if water is in the form of ice, so you cannot say the ice is flowing. It can float over the water on the water, but you cannot say it is flowing. Okay. So
Mhm.
this is the second point. What is the second point? That in every state, the substance will have different characteristics. The substance is same, just like the
Mhm.
water. I told you the example of water. For example, water, if you see, in the solid form, it will be ice, right? In the liquid form, it will be known as water, maybe. In the gas form, it will be water vapors, right?
Mhm.
So in all these three states, it has difference. Although the composition is this HOH, the composition of water is what? H2O, right? Actually, we make it
Yeah.
like this. The diagram is like this. You have oxygen, you have hydrogen, and hydrogen. You have lone pairs. This is water. This is same in ice, in water vapors. But the difference is only over here that in ice, there is compact packing of the particles. Like you have many of the water molecules, and those are compact. Okay, they are closely placed.
Mhm.
While in water, there will be some spaces. While in the form of vapors or in the form of gas, there will be very less spaces. Okay, there will be no intermolecular interaction. Clear?
Mhm.
So this is the second point. The explanation of second point is this. You can give this example if you want in your paper. Like what are the different characteristics in each state? You will say in different state, even though the species same, the chemical is same, this chemical is same, but in different forms it will have different characteristics. Clear?
Mhm. Yeah.
Okay. Now the third point is the differences are due to the way its particles are arranged and move in each state. Now they have explained what
Mhm.
I have already explained, that the difference are due to the way its particles are arranged, move in each state. Did you get this point, the third point? What they are saying in the third point? Read this.
Uh, like the
Hmm.
difference are due to the way its particles are arranged and move
Hmm.
in each state.
Hmm. In the
Like
second,
different
yeah,
particles
it is
are
the
arranged
explanation
and
of the second point. It is the explanation of the second point. Start
yeah.
reading from the first point. What is this?
A substance that can be a solid, a liquid, or gas can and change from one state to another.
And did you
Second,
get this?
it has different.
You got the first point?
Yeah, that is. Yeah,
Hmm.
yeah. It can be solid, gas, or liquid, or can change.
Yes. Like a gas can, you can convert a gas into liquid. You can convert a liquid into solid as
Uh,
well, just like by freezing the water. If you place the water in the refrigerator,
yeah.
it will become ice. Okay. Yes.
Yes.
Next.
Second, it has different characteristics in each state. For example, solids do not flow.
Hmm. What example you can
Uh,
give instead of this? Like this one. Can you explain
that
this example?
water vapor only comes in gases.
Like if you have water, and you know what are the three states of water? What can be the three states? In the solid, what water looks like? It looks like the ice, right? In the liquid,
Yes.
it is liquid water. And when we say in
Yeah.
the gas, it is in the form of water vapors. Okay. So in all
Yeah.
these three states, the water, the composition of water is same. The hydrogen and oxygen. The composition of water is same. But in all these
Mhm.
three states, what is the difference? The
Mhm.
difference is in their characteristics. Okay, like the ice is different from the liquid water, and
Yeah.
liquid water is different from the ice. Similarly, the ice is different from the water vapors in the gas form, and the water liquid water is different from the gas. And why they are different? Read the third point.
Mhm. Uh, the differences are due to the way its particles are arranged and move in each state.
Hmm. So this is the difference. Why
So,
they are
like
different?
solids are packed
Hmm. Like in ice,
because of the
you can give
particle
this example.
arrangement,
Explain
and
this example according to third point. This example, ice, water, liquid water, and water vapor. What is the difference in these three? Ice, liquid water, and water
ice
vapor.
is ice has ice is like a ice has
Hmm.
packed particles
Yes,
and cannot
the
move
particles are
freely,
close to each
and
other.
liquid water can
Hmm.
yeah, closely packed, and the liquid water is a little bit far apart but
Hmm. The
has
particles,
space
you
to
will
move
say,
apart.
water is not far apart. You know what does it mean? It means what you are saying is that there is some water over here, there is some water over here. It is not the case. You will say the particles are far apart.
Water part.
Because we are studying kinetic particle theory. Okay, it explains the particle arrangement, how particles are arranged. Okay, next, liquid water.
And what water vapors, the particles are
Hmm,
free can move free
can
anywhere.
move freely. Yes. So these are the differences. So this they have mentioned. The differences are due to the way its particles are arranged. It means
Mhm.
the solid particle or the liquid particle or the gas particle, how they are arranged, how they move in each state. On these basis, we have three different categories. Okay,
Mhm.
and in every category, like in solids, they have some specific properties. The solids follow some specific properties, then liquid follow some specific, and then water vapors. Clear? This is
Mhm.
known as kinetic particle theory. Can kinetic mean motion or movement? Okay, these
Mhm.
are the three postulates. This is very important. This is asked. They directly ask you sometimes the postulates of the kinetic particle theory. Okay, the postulates of
Mhm.
kinetic particular theory. Postulates.
Mhm.
Clear? Are you done with this?
Yes.
Okay. Now move on to the next part. I am erasing this if you have taken the screenshot. You can take the
Yeah, I
screenshot.
got
Okay, now I
already.
am erasing this because I have to read from here. Yes. How much heat is needed? Why they have discussed about the heat? What is the purpose of heat?
Uh,
Hmm. We have discussed in
like
the start of this lecture. Yeah. To
so, like
to break
it
the
forces.
yes, to break the heat is needed to break intermolecular forces. Okay. Now they are asking how you will get to know how much heat is needed. Like if you are heating, if you want to convert a solid into liquid. So how you will know this?
Mm-hmm.
How much heat is needed? Hmm? It depends on the
Hun
arrangement of the
100.
particles. Sorry.
Okay.
No, you cannot
No,
say the 100
like.
degree. 100 degrees that is specific for water. Remember that
Oh.
thing that is not universal for everything. Okay, for every compound, for every chemical, you have different values. And why they are different? Because the
Mm.
bonding is different. The particle arrangement is
Yeah, the
different.
force.
Okay. Yeah.
Mm.
So, how much heat is needed? It depends on the particles. How many particles are there? Obviously, if you have two substances, let's say in one substance there are 1,000 particles, right? I am writing over here. You have two substances. In one substance there are 1,000 particles, and in the other there are 2,500 particles. This is substance A, this is substance B. Which particle will need more heat? This is solid.
So,
This solid A, solid B. Which solid need
solid B.
solid?
Solid B.
Yes. So this is what they are saying. It depends on the particles in each substance because in different substances, solid, not all solids are same. You have laptop, the laptop in this the particles are different. In the table, the particles are different. In everything, the particles are different. So how much heat is needed? It depends on the particles. If there are more particles, obviously you will need more heat to break those to separate those particles. First thing is it depends on the particle. Okay, how much particles are there. Second thing is forces. If the forces are strong, then obviously you need more heat. Clear?
Yeah.
So there are two main things. You can highlight this. Firstly, the number of particles and the how much heat is needed. It depends on the number of particles. If there are more particles, then there will be more heat needed. And second thing is about the forces.
Mm-hmm.
Clear?
Mm, yeah.
Okay. Can we move forward? Are you do you
Yeah.
have any? Okay.
Yes. Yeah.
Now we have reversing the change. Now what we are doing initially in the previous lecture we discussed that you have a solid, then from solid the liquid formed by melting, right? By melting
Mm. Yeah.
at 0 degree Celsius. Yeah, the melting point is 0 degree, while the
Mm-hmm.
boiling point is 100 degree. For water, melting point is 0 degree, like from the ice. And from water to from the steam or the gas, you need 100 degrees Celsius. So they are saying
Mm-hmm.
as it warm up, some evaporate. Now they have mentioned some will evaporate. Why all substances cannot evaporate? My question is that when you are boiling, why all substances cannot evaporate?
Uh, Maybe because
Hmm? Because you see inside over here there is already boiling happening, right? So
mhm.
you cannot say that all the substances can evaporate because there will be very few substances on the surface, and those few substances, when they gain enough energy, they will leave the surface. Okay, so you can say that evaporation, not all the, as a whole, this substance cannot evaporate because evaporation is a surface phenomena. Only those particles which are present on the surface will evaporate. But the particles present inside the liquid, they will not evaporate. That's the reason that even though you have high temperature, but not all the substances, all the particles evaporate at in few time. Maybe you need more time to evaporate all the substances, all of the substance.
Mm-hmm.
Clear? Then there is opposite. Opposite is that you have gas, okay? You have the gas, and what you need to do is, as you cool it below 100 degree, the water vapor begin to condense. What they're saying, the steam will form at 100 degree or beyond that, right? So when you
Yeah.
reduce the temperature, what you need to do when okay, we are going reverse in the reverse direction. So the process will also be opposite. Over here there was evaporation, right? Now you need to do what you need to do, you will decrease the temperature. Okay, as you cool it below 100 degrees Celsius, it means you are decreasing temperature. When you are going back, you are decreasing the temperature, right?
Mm-hmm.
Clear?
Yeah.
So this is first thing. Whenever there is a question, there will be a question that there is gas, and that gas you have to convert that gas into water. So your answer must define that you will decrease the temperature. Okay, and the second thing will happen is known as condensation. There will be condensation. Okay, this was what this was melting. This was boiling, right?
Mm-hmm.
Now the opposite of boiling is what? That is condensation. Okay. What is meant by condensation? Actually, in gas, the what is the particular arrangement of in the gas? How particles are arranged?
Far apart, like freely
Hmm.
moving.
They can freely move. So if you want to convert in liquid, what you need to do? Firstly, you will decrease temperature. Otherwise, what will happen?
It won't. Well,
If you don't decrease temperature and you are continuously increasing the temperature, evaporation will increase. Okay. So
oh.
ultimately, there will be more gas formation and less liquid will be available. So if you want to convert gas into liquid, gas into water, you need to decrease the temperature, okay? And when you decrease
Mm-hmm.
the temperature, the water vapor begins to condense, okay? The water vapor will condense. Condense means they will come closer to each other. And when they will come closer to each other, so the liquid will form. In the liquid, there are strong intermolecular forces as compared to the gas. Okay, in the liquid there are more intermolecular forces as compared to the gas. Are you
Mm-hmm.
getting my point? What is condensation? Condensation means
Yeah.
that particles will gather at one place. Okay, and when they will gather, what will happen? Their intermolecular interactions will increase. Ultimately,
Yeah.
that gas is converting into liquid. I can write it over here as well. I'm saying you have basically you have what? There was a solid. Now we can do the reverse part. There is a gas, okay, and you need to convert it into liquid. What you will do? First thing is I told you, decrease the temperature. Okay.
Mhm.
Then when you will decrease, ultimately what will happen? The particles will condense. Okay. Particles will
Mhm.
condense, and once the particles condense, the liquid will form. Right. In the gas, the particles are they have the arrangement like this. This is a gas, maybe. Okay. But in liquid, what will happen? They will come close to each other. Clear?
Mhm.
So this is a liquid. Okay, you see the difference. In the gas, the particles are far apart. When you decrease the temperature, what will happen? The particles will start to condense. And when they will condense, what will happen? The liquid will form. Okay.
Yeah.
This process is known as condensation. What it is known as? It is known as condensation. Clear?
Yes.
Okay, now your homework for this is to write about firstly, what is the melting, then boiling,
Mhm.
then condensation. Okay, and
Okay.
then you have to tell what is the difference